In this video, we'll be talking on Fourier series. And Fourier series is a method of analyzing periodic functions into its constituent components. Okay, and then we'll talk on Fourier series for periodic function. We talk about Fourier series for non-periodic functions. We talk about even and odd functions, average series, and Fourier series over any range, including the harmonic analysis. Now, a period is said to be periodic, or a function is said to be periodic if it repeats itself over a period of time at equal intervals, and it is non-periodic, or what you might also call aperiodic, when it doesn't repeat itself. Now, it can repeat itself over a range of 0, less than x, less than 2 pi, or over the range of minus pi, less than x, less than pi. Now, what is the formula for Fourier series? Okay, this series consists of terms, of 3 terms. We have a naught, we have an, and we have bn. Now, Fourier series is represented by f of x is equal to a naught over 2 plus summation from n is equals to 1 to infinity of an cos nx plus bn sine nx. And we can see the efficacy of a naught as a constant term, an, bn. Now, since we'll be using a lot of trigonometric function, most essentially the use of sine and cos, now there is a need for us to establish some facts. Taking a look at the Cartesian plane, which ranges from 0 degrees to 90 degrees to 180 degrees to 70 degrees and back to 360 degrees. And 0 degrees is equivalent to 0 pi in radians. Radians, this is equivalent to 2 pi. Okay, and this is equivalent, 180 degrees is equivalent to pi in radians. Henceforth, we are saying this is pi over 2, 90 degrees is pi over 2, and 270 degrees is 3 pi over 2. Now, since we will be dealing a lot with radian instead of degrees, there is a need for us to know what is sine pi, what is cos pi, what is sine pi over 2, what is cos pi over 2, what is sine pi, what is sine 3 pi over 2, and what is cos 3 pi over 2, what is sine 2 pi, and what is cos 2 pi. Our understanding of this will go a very long way. So instead of pressing calculator to evaluate sine pi cos pi, sine 2 pi cos 2 pi, then we can easily go straight to the point and evaluate it. Now, going back to the Cartesian plane, we know that this is the positive x-axis and this is the negative x-axis. This is the positive y-axis and this is the negative y-axis. Now the rule is simple. The x-axis belongs to cosine and the y-axis belongs to sine. So any form of sine on the x-axis is 0. So sine 2 pi, since 2 pi and pi, 2 pi and pi falls on the x-axis, definitely sine pi and sine 2 pi are equal to 0 because the x-axis belongs to the cosine. Now cos 2 pi on the other hand, cos 2 pi on the other hand and cos pi are on the x-axis, and since x-axis belongs to the cosine, so definitely they will have their values. Now if we look at 2 pi, 2 pi stands on the positive x and pi stands on the negative x. So we can say that cos 2 pi is equals to 1 and cos pi is equal to minus 1. Now going back to the y-axis, the y-axis belongs to sine, so any form of cos function will be equivalent to 0. So we are saying cos pi over 2 is 0 and cos 3 pi over 2 is equal to 0. And since the y-axis is also equivalent to sine, we are saying that the sine pi over 2 and the sine 3 pi over 2 will have its values. So in essence, since sine pi over 2 stands on the positive y-axis, we can say that sine pi over 2 is equals to plus 1. And since sine 3 pi over 2 belongs to the negative y, we can say that sine 3 pi over 2 is equal to minus 1. So having come to these conclusions of sine pi is equals to 0, cos pi is equals to minus 1, sine 2 pi is equals to 0, cos 2 pi is equals to plus 1, sine pi over 2 is equals to plus 1, cos pi over 2 is equals to 0, sine 3 pi over 2 is equals to minus 1, and cos 3 pi over 2 is equal to 0. Now, let's talk on how do we integrate the terms of cosine and sine. But before then, going back to this formula, f of x is equals to a naught over 2 plus summation of n is equals to 1 to infinity of an cos n x plus bn sine nx. What is an? What is a naught? What is an? And what is bn? Okay, now we will be doing this in accordance to the range we are given. So we might be given the range of 0 less than x less than or equal to 2 pi, and also the range of minus pi less than or equals to x less than or equals to pi. Now we evaluate a naught. What is the formula for a naught? A naught is 1 over pi integral of 0 to 2 pi of function f of x dx. An on the other hand is 1 over pi. The range is 0 to 2 pi. F of x cos nx dx. And bn is 1 over pi from the range of 0 to 2 pi. of f of x sine nx dx. And if we move over to the range of minus pi less than x less than or equals to pi, we will notice that it will be the range that will change. Okay, instead of having 0 and 2 pi, we'll be having minus pi to pi. But the constant form here, 1 over pi, will be the same. So in essence, we are saying this will be equals to a naught is 1 over pi integral from minus pi to pi of f of x dx. En is equal to 1 over pi integral of minus pi to pi f of x cos nx dx, and Bn is equal to 1 over pi integral of minus pi to pi f of x sine nx dx. Now we can see a lot of integration going on here and a lot of differentiation going on here. We will do a lot of integration and as well a lot of differentiation, and which comes with differentiation of and integration of trigonometric function. So let's take for instance, we have 3 columns. One is f of x, and the next column will be what is the result when we differentiate f of x with respect to x, and the third column will be what happens where we integrate f of x with respect to the x. Okay, now we will talk about integrating if f of x, or what we call y. The first thing we say is if y is equals to x raised to power a x raised to power n. When we differentiate this, we will have nax n raised to power n minus 1, and when we integrate it, we will have ax n plus 1 divided by n plus 1. If y is equal to sine x, differentiating sine x will give us cos x, and integrating sine x will give us minus cos x. What about y is equal to cos x? Differentiating cos x, we will have minus sine x, and integrating cos x, we will have sine x. Now, just to add a bit more, for if y is equal to sine nx, differentiating sine nx, we will have n sine nx, and integrating sine nx, we will have sine nx over n. Number 5, if y is equal to cos nx, differentiating cos nx, we will have n, okay, should be n cos nx. Apologies, let's go back. Differentiating sine nx, we would have n cos nx, and integrating sine nx, we would have minus cos nx divided by n. Now integrating cos nx, we would have, or differentiating cos nx, we would have minus n sine nx, and integrating cos nx, we would have sine nx divided by n. Now, a lot on this will be explained in an upcoming video on calculus, where we differentiate sine and when we integrate cos, and what happens when we have a function embedded inside another function, what we mostly call chain rule, or function of a function. Now let's add two more rules to this. What happens when we differentiate and integrate sine nx over n, and when we differentiate and integrate cos nx over n? Differentiating cos sine nx over n, we will not focus on the differentiation. However, let us focus on the integration. So, integrating sine nx over n, we would have minus cos nx over n squared. And integrating cos nx over n, we would have sine nx over n squared. Now, this table will be very useful when we deal with Fourier series, because we will focus more on the integration of sine x, cos x, sine nx, cos nx, sine nx over n, cos nx over n. And once we understand this table, and as well as this table, we can proceed. So in our next video, we will talk on Fourier series for periodic function of period 2 pi. We'll be taking two detailed examples on it, and we move on.